Hello friends, welcome to today's lecture Principal Stresses and Strains. Myself, Mr. Y. S. Patil, Department of Civil Engineering, Sharad Institute of Technology, College of Engineering, Gurgaon. So in this last lecture, we studied about a bar or a section is subjected to unique force, that is a single force, and what are the normal stresses are produced in the that section and the tangential stresses. Same in this lecture we discuss about a member is subjected to like direct stresses in two mutually perpendicular direction. Basically first, like direct stresses means the both stresses are in same direction or same in nature. Means suppose this is the and two mutually perpendicular means what? The two poles are perpendicular to each other. So basically see first sketch of this statement. This is a subject, means that is ABCD. On that face BC is acting sigma 1, that is stress sigma 1 in tension in nature. And this is the face CD, and on that face CD force acting or that stress is sigma 2, and that sigma 2 also in tension. The sigma 1 and sigma 2 both are in tension. Then this system called as like parallel forces. Like forces. Like means both forces are in same nature. And that sigma 1 and sigma 2 are mutually perpendicular to each other. Now we require to find out normal stress and shear stress. The procedure to find out normal stress and shear stress is as it is we discussed in first lecture of the principal planes and stress. Now I want to find out normal stresses and tangential stresses on that line FC. On that line FC. So in that FC directly that sigma 1 and sigma 2 also acting. So this is the sigma 1 and this is the sigma 2, or on the bottom side that is sigma 2. Okay. First of all we require to resolve this sigma 1 and sigma 2. Sigma 1, that is the stress induced or stress applied on the face BC. So I want to convert that force, that stress into force. How to convert that stress into force? That like this. That I want to calculate P1. P1 is equal to sigma 1, that is stress on the face BC, into BC length into 1. 1 is the unit thickness of that BC section. So now P1 is equal to sigma 1 into BC into 1. It becomes now P1. Similar way we calculate P2. P2 is equal to sigma 2 into shear BF into 1. So now it becomes P2. Then sigma n is equal to, means normal stress is equal to Pn divided by area of FC, and sigma t is equal to Pt divided by FC. Then we calculate P1. How to calculate that with respect to that FC, that P1 and P2 acting perpendicular to each other at an angle. Suppose P1 is at an angle of theta with respect to the normal. Then P2 also angle is theta with respect to the FC line. Okay. Then P1 becomes the x component, that is horizontal component is P1 sin theta, and vertical component is P1 cos theta. Similar way calculate P2. That P2 is theta with respect to, suppose this is the consider horizontal line or that x line. So with respect to x, That's why the P2 x component becomes P2 cos theta and y component becomes P2 sin theta. Then Pn total, that sigma n is equal to Pn divided by area. So Pn becomes, normal force becomes, that is P1 cos theta plus P2 sin theta. Okay, this is the P1. Put up this P1 and P2, P1 cos theta and P2 sin theta divided by area of FC. By solving this equation, we get sigma n is equal to normal stress, that is sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 into cos 2 theta. This is the normal stress. Sigma 1 means stress on this BC, sigma 2 means stress on this CD. Then next, sigma T, tangential stress. For sigma T, we require to find out tangential force, that is PT. How to calculate PT? PT is equal to P1 sin theta plus P2 cos theta. P1 sin theta plus P2 sin theta. This is the total force of PT. And PT divided by area of this FC, it becomes sigma T. So by putting this P1 sin theta, P2 sin theta and area of the FC value, it becomes sigma T is equal to sigma 1 minus sigma 2 divided by 2 into sin 2 theta. So this is the normal stress and this is the tangential stress on this section. Then this is the normal stress, that is sigma n, and this is the tangential stress sigma t. Now we calculate resultant stress, that is sigma r. Sigma r is calculated by taking square root of sigma n square plus sigma t square. This is the sigma r, and the direction of that sigma r is calculated by using tan phi is equal to sigma t divided by sigma n, where phi is a obliquity. Phi is a obliquity. It is angle made by the resultant stress with the normal of the oblique plane. This is denoted by phi. Then maximum shear stress is, that is sigma T max is sigma 1 minus sigma 2 divided by 2. So this is a solution for a member subjected to like direct stresses in two mutually perpendicular direction. Suppose in the problem they are given unlike forces. Unlike forces means what? Sigma 1 tension, sigma 2 compression. Then we consider tension as a positive, compression as a negative. Sigma 1 value will be positive, sigma 2 value will be negative. And by considering that sign, we can solve this problem by using these all formulas. That is sigma n. Once again I repeat, sigma n is equal to sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 into cos 2 theta. Then sigma t is equal to sigma 1 minus sigma 2 divided by 2 into sin 2 theta. And the resultant stress is square root of sigma n square plus sigma t square. And that obliquity is tan phi is equal to sigma t divided by sigma n. And the maximum shear stress, that is sigma t max, is sigma 1 minus sigma 2 divided by 2. These formulae are important formulae to solving this type of problem. So let us see one problem. A tensile stress at a point across two mutually perpendicular planes are 120 Newton per mm square and 60 Newton per mm square. Determine the normal stress comma, tangential stress, resultant stress on a plane inclined at a 30 degree to the axis of minor stress. First, mention the given data, that is major stress is considered now sigma 1 is 120 Newton per mm square. Minor principal stress sigma 2 becomes 60 Newton per mm square. Now they are not mentioning nature of the stress, so we consider both are like stresses, that is tension, and the inclination of the plane is 30 degree to the minor axis. Then find out normal stress. Sigma n, the formula to find out normal stress for two mutually perpendicular forces acting on a section, sorry, they are mentioning tension. Sigma n is equal to sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 into cos 2 theta. Sigma 1 is 120, sigma 2 is a 60, and theta becomes 30. So put up all values in the equation and calculate normal stress. So normal stress become 105 Newton per mm square. Similarly, we calculate tangential stress, that is sigma t. For sigma t, equation is sigma 1 minus sigma 2 divided by 2 into sine 2 theta. So sigma 1 is 120 minus 60 divided by 2 into sine 2 into 30. Once again, I sine 2 theta means you multiply by angle with 2, and that is 2 into 30 is 60, and you calculate sine 60. It is a right procedure to calculate sine 2 theta. Then sigma t becomes 25.98 Newton per mm square. Then resultant stress sigma r is equal to square root of sigma n square plus sigma t square. Sigma r is equal to 105 square plus 25.98 square, and take the square root of that answer, that is sigma r is 108.16 Newton per mm square. So let us see one more problem. A point is strained on a material. The principal stresses are 100 Newton per mm square tensile and 60 Newton per mm square compressive. Determine the normal stress, shear stress, and the resultant stress on a plane inclined at 50 degree to the major axis, that is major principal axis. Also determine the maximum shear stress at a point. Now in this problem they are mentioning two stresses, and that both stresses, the nature of the stress is different. So first is major principal stress, that is sigma 1 is 100 Newton per mm square, and the nature of the stress is tensile, so it consider positive. Then minor principal stress, that is sigma 2, the nature of the principal stress is compressive, so consider negative, and the magnitude is 60 Newton per mm square. Now in this problem the inclination of the plane is given 50 degree, but that the plane is 50 degree, theta is given with respect to major principal stress, that is major axis, and we required to find that theta with respect to minor principal stress. So it becomes theta is 90 minus 50, so theta becomes 40. We cannot use directly this 50 degree because that 50 degree is with respect to major principal stress. I want to convert this 50 degree or there is theta with respect to minor principal stress. So theta becomes 90 minus 50 is 40 degree. Then now find out normal stress. Normal stress sigma n is equal to sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 into cos 2 theta. Put up all values. Now sigma 1 is plus 100 and sigma 2 is minus 60. So use this with considering sign, that is 100 minus plus, that is in bracket minus 60 divided by 2 plus 100 minus in bracket minus 60 divided by 2 into cos 2 theta, that is 2 into 40. So put up all values in this equation and calculate normal stress, that is 33.89 Newton per mm square. Then tangential stress, sigma t is equal to sigma 1 minus sigma 2 divided by 2 into sin 2 theta, 120 minus into minus 60 divided by 2 into sin 2 into 40. So sigma t becomes 67.78 Newton per mm square. Then sigma r, that is resultant stress, is square root of sigma n square plus sigma t square, and that is sigma r is 85.76 Newton per mm square. Then we require to find out maximum shear stress, that is sigma t max. For sigma t max, sigma 1 minus sigma 2 divided by 2. Now sigma 1 is 100 and sigma 2 is minus 60. So minus minus plus 60, that is 100 plus 60 is 160 divided by 2. The tangent maximum shear stress sigma t max is 80 Newton per mm square. This is a solution for a member subjected to two mutually perpendicular stresses. Thank you.